Welcome to phase 2 of the course. Well done for making it this far. We've covered the Python foundations up to this point. Now we start building the skills that will make code production ready. And in this lesson, which is probably the most important in phase 2, we're going to look at how we handle errors, because as we go through the course, we're aiming towards building an AI agent, and that will make external API calls, read files, process data, and at any point, if something falls over, we need to be able to finish the program or capture the error cleanly. Without error handling, one network timeout crash and the entire run loses all progress. By the end of this lesson, your code will handle failures gracefully, log them, recover, and keep going. So let's get on some coding. Python will stop completely when it hits an unhandled error. Let me show you what I mean. With this particular code, if I run this now, you see that an error appears on the screen. And that's because what we're trying to do is trying to take a string value there of 3000 and take 250 away. So there's a difference in the data type involved. So Python throws an error in our output screen. Now imagine you're processing hundreds of claims. That means you lose everything. Error handling wraps the risky code and tells Python what to do when something goes wrong instead of just stopping abruptly. So how do we deal with this? Well, you put the risky code inside a try block. If an error occurs, Python jumps to the except block instead of crashing. Then execution continues normally after that try except construct. Okay, so let's run this and we'll see what happens. So we had the error, but the error was trapped. The main run code that we had was inside this try block here. Same calculation, it was bound to fail. But now that we have this try construct and we have an except type error section here, the error is caught, we print a useful message, and the script keeps running. Notice I've named the specific exception called type error. Always catch a specific exception type rather than a bare except with nothing after it. A bare except catches absolutely everything, including keyboard interrupts, system errors, which can hide bugs in your code and make code very hard to debug. So here we're saying we're only capturing an error when it's a type error. Okay, and ours was indeed a type error. It was related to the data type. So we went through cleanly, caught the error, and then it carried on and printed processing continues without just falling over and your whole program coming to an abrupt halt. Different errors need different responses sometimes. You can have multiple except blocks, each handling a different type of error. Python checks them in order and uses the first match that it comes across. So it goes through each of the except blocks, and if it matches that particular error, then fine, it will deal with it according to that block. So in this case, you see on the screen, if it's a key error, then it will print that the particular key isn't found, and then it will come out of that function. If it wasn't a key error, it would go on to the next one. But as soon as it finds the one that fits that particular error, then it'll fall to the end and come out of that function that we've declared to capture the excepts. So let's run this particular piece of code because we've got multiple errors in here and they're handled in different ways. So let's have a look at the output. So the first time we're sending through claim 002. Here's our list. So claim 002 is a 3500 is the value, and the excess is 250. So it goes through the cycle, and there's no error there. Everything's fine. You've got a value which is greater than excess, calculates the excess, returns the payout, and we print it. Second time around, we're sending through claim 007. Okay, now claim 007, if you look at our list, the actual value is a string. So there we're expecting a data type error. And sure enough, it falls into the type error here. Okay, and it says invalid data typing claim 007. Third time round, we've got claim 999. Now, claim 999 doesn't exist in our list, so it says it's not found. It's a key error, meaning the key is not found, okay, in the list that we're going through. So what it does, it says it's not found, and it falls to the end and returns just none, okay? So we've got multiple errors being trapped inside our function. We've got multiple except blocks, okay? And each except deals with a different type of error. We've seen a key error being captured, we've seen a type error being captured, and we've seen the program handle them and not fall over. So it finishes everything cleanly and handles our errors. So I want to show you now 2 more optional blocks that we can include in our code. In this particular example, else will only run if no exception was raised. Okay, so we've got the except above it to capture value errors, but if no exception is raised, then it will go to else. And finally, always runs no matter what happened, every single time, even if an exception was raised. And this is perfect for cleanups and for logging. So when you're going through thousands and thousands of records and you want to log or create an audit trail of what you've processed, whether there was an error or not, this is ideal. You can put it into the finally section. So in this particular case, every single time it runs through, it will produce processing complete. And you could have that writing to a log if you wanted to. So when we come to building our final project, we could do something like a log for every API call that we make. So there's an audit trail for what we sent to our LLM through the API call, regardless of what the outcome is. So far, we've been catching errors Python raises, but you can raise errors yourself using the raise keyword. Use it to enforce your own rules. If data doesn't meet your requirements, reject it immediately rather than letting it sit there as bad data, silently corrupting your results further down the line. Okay, now let me demonstrate this. What I've got is I've got a function called validate claim. In this function, if you look at these if statements here, we're saying if the ID is not in claim, meaning if there's no ID value being sent to the validate claim. Because remember, if you look down here, the way we call this function, we send an ID and we send a value, okay? So we say the claim ID and we send the value of that claim as a dictionary into this function. And that's the parameter we use, claim. Now, if the ID doesn't exist, then we raise a value error saying the claim must have an ID field. In this one, we say if the value that's being sent is not an integer or a float, then we say the claim value must be numeric. We're saying claim values must be numeric. We got a whatever the type is for that particular value coming through for the claim, okay? And the name is just saying what's the name of the type that's been actually sent. And if the claim value is less than 0, then we're saying we're going to raise a value error. Okay, so we've got 2 types of value error there, and we've got a type error in there. So here are our calls. We're sending, the first time we're sending ID of claim 002 and a value of 3500. And we'll say we'll print the claim as valid, except when there's a value error or a type error, in which case we're going to say the validation failed. In the second one, we're sending an ID of claim 008 and a value of -10, except, again, if there's a value error or a type error, in which case we will print what that failure is. And in the third case, we're sending an ID of claim 007 and we're sending a value of a string here. So we know that's going to be captured up there. And once again, if it's a value or a type error, we're going to print the actual failure. And we're going to print the error that's being returned. So when we run that, we get claim 002 is valid because there's nothing wrong with that particular argument being sent. We're saying for the second one that the value must be positive, i.e. it cannot be a negative value. And we're capturing this here. If the value is less than 0, then raise a value error. So claim value cannot be negative, and we print the value of that claim, okay? Which we've done here. And in the third case, we're sending an ID of claim 007 with a value of a string. Now, when it gets up here, it falls into this if statement, where it checks that the value is actually an integer or a float. Because it's not, it's going to fall in here and saying, claim value must be numeric, but I got a whatever the data type is. And when we run that, we get these outputs. So that's a way of actually defining your own error criteria. Very useful when you want to enforce your own rules. You can actually create your own exception type. So we're going to discuss custom exceptions here. This makes your code far more expressive. So instead of using a generic value error, you raise something called a claim validation error. Okay, that tells you exactly what type of problem has occurred. And to do this, we use classes. Now, a class is like a blueprint for creating objects. So imagine within Python, there's a class of object called exception, which deals with exceptions in your code. We're now going to use that blueprint for an exception and create our own exception. So in our class definition there for claim validation error, we're saying, here's a class that we're creating. We're going to base it upon what already exists in Python, which is called an exception class. And we're going to say, this is what this particular class does. Now, in our example, all we've done is put some text in to say this is raised when claim fails its validation. And we use this dummy line called pass because we need at least one line within the class definition. And we've also created one called API responses. Now, we won't be using this in this particular example, but we will use it further on when we get towards using API calls. Bear with me and we're going to go through the rest of the code now. So we've defined our function called validate claim. If the value of the claim is less than or equal to 0, we're going to raise our claim validation error. So instead of raising a type error or a value error, we're raising our own defined error here. And it's based upon exceptions in Python. We've inherited everything that a normal exception does, but we've called it something different. And we'll define when it's raised. So in this case, if the value is less than or equal to 0, we're going to raise our exception class, which is claim validation error. And what we've done in there, we've said, here's what's going to get printed. So we've given a format for what has to be printed back to the user. Now we're going to call it. So we're using our try block. Okay, we're going to say validate claim. The claim is claim 011. The value is -50. If there's an exception raised in the function called claim validation error, then we print there's a claim error and we give the error. If there was an exception raised called APIResponseError, we're then going to print there's an API error. Okay, so what we've done is we've said we are handling our own named exception here. We've defined what the exception is in our function. It happens when the value of the claim is less than 0, and we're handling it in our call because the function will return that particular exception back to us. So the function determines whether there's actually an exception raised, and the try block captures that and uses it to determine what type of print statement we're going to put. So in this case, the function determined because the value is less than 0, we're going to raise a claim validation error. That goes back to the calling routine. It traps that claim validation error and prints the error. Notice that as E syntax, that captures the exception object so we can print its message. Very useful for logging exactly what went wrong. Now, at the end of this project, we're actually going to be creating an API call to the LLM. So how will we actually handle errors when we're making that call? So I'm just going to simulate here how we're going to do error handling when we actually make our call to the LLM at the end of this entire project. So we're doing an import of the time library because we're going to use a delay counter. And we're defining our function called call LLM API. 2 parameters in there, the prompt and the number of tries we're going to make. Now remember, when we've got a range, the range we put down 1 to say 5, the range goes 1, 2, 3, and 4, stops before the final number. So in this case, we've got maximum tries of 3. So we're increasing it to 4. So it actually goes from 1 to 4, but stops at 3. So we actually get those 3 retries, okay? First thing we do is we're going to simulate our call to the API. Now, if that call fails, then, and the number of attempts is less than 3, we're going to raise a connection error. Otherwise, we're going to create our response and return that response, okay, to the calling routine. And we've defined down the bottom what the connection error is, okay. Now, when we get a connection failure, we're going to sleep for 2 seconds, and then it will go back up into the loop and try again up to the maximum tries, which is going to be 3. Any other exception, we get an unexpected error being used. We break out of the loop. So down here is our call. We're going to call the API. That's our prompt. Write a claims letter for claim 002. And we'll actually print, when it returns, it will print the first 50 characters of that letter. So there's our call. We go up to here. Our prompt goes into there. We're doing 3 tries. Here's our try and it's failed. That's our simulation. Okay, we're actually going to do a call when we actually come to the actual routine. Now, if the attempts are less than 3 so far, we're going to raise a connection error. Otherwise, we'll respond with a successful, dear policyholder, your claim has been assessed, and return that back to the calling routine. And we've got our 2 exceptions. So what we've done is we've created a function there that handles our errors, okay, and does reattempts, okay, if there's a failure to connect to an API that we're calling. So in summary, we've covered quite a lot in this particular lesson. So remember this: try wraps risky code and accept catches it when it goes wrong. Now I suggest you always name your exception types as we did. Never use a bare except. Multiple except blocks handle different errors differently. So you don't want to have one particular except block for all errors. Else will only run on the success. Finally always runs. Go back to that section where we used else and finally and understand that routine, because it's really useful, especially when you want to do logging. Raise lets you enforce your own rules and signal problems deliberately. And custom exceptions make your code more expressive and easy to debug. And then finally, we looked at this retry pattern where the try except inside a loop, and that would be exactly how we do it when we actually come to our API call. Hopefully you found that useful, and I'll see you in the next lesson.